Assalamualaikum and hello to all. We are going to proceed to chapter 7, which is a new topic about chemical bonding. So this is part 1. So today we are going to study about the Lewis dot symbol, the octet rules, and how to obtain the octet configuration. And we are going to also study about ionic and covalent bond. And if we can, we are going to study how to draw Lewis structure, calculate the formal charge, and explain the exception to the octet rule, whether it is incomplete, expanded, or odd number electron. Okay, Lewis dot symbol. So a Lewis dot symbol is actually a symbol of element and dot for each valence of the electron. Okay, for example, if we refer to this one, group 1, lithium, so there is one valence electron, so you just put 1 here. Okay, let's say you do not want to put it there, you want to put it here, it is also correct. You do not want to put it there, you want to put it at the bottom, also okay, no problem. For single electron is also okay, but for me usually we put it here. And for beryllium there are two valence electron. You can put it like this. Okay, you can put it like this, you can put it like this, or you can put it like this. Okay, also okay, but usually we are going to put it like this. Okay, 3, how are we going to put 3 electron? You are going to put it 3 like this, or 3 like this, also okay, or you want to put it here, also okay, no problem. But usually for this one we are going to put it like this. And carbon there are 4, so you can choose to draw like this, 1 2 3 4, or you want to um, use lone pair like this. You can also put it like this, or like this, also okay. Okay, all are accepted. Nitrogen there are 5. Usually we write down like this. Okay, this, but it is not good for you to draw 1 2 3 4 5 like this. Okay, usually we spread it up in pairs. Okay, in pairs. Okay, so this one better if you put it like this. This is dot actually, but the ink here is too small for you to see. And 6, so 1 2 3 4 5 6, fluorine 7, 1 2 3 4 5 6 7, and neon is 8. So this is octet. 1 2 3 4 5 6 7 8. Okay, so that is the symbol of element with one dot for each valence electron to show that this is Lewis dot symbol. Octet rule. So what is octet rule? Octet rule is the theory that main group tends to bond in such a way that each atom has 8 electrons. Octet from the word octagon, right? So octet is 8 lah. In its valence shell, giving the same electronic configuration as noble gas. Noble gas here we are referring to gas at the group 18. So it have octet configuration. So when atoms have fewer than 8 electrons, they usually tend to react and form more stable compound. So atom can achieve noble gas configuration or octet configuration whether they transfer electron. Transfer means maybe they can uh, remove electron or gain electron, or sharing of electron. Okay, sharing of electron is covalent bond, right? So first, ionic bond. So what is ionic bond? It is actually electrostatic forces between the cation and anion that attract one another in ionic compound. And this usually happens due to transfer of electron. Okay, transfer of electron means one receive the electron, one give the electron. And it can only happen between metal and non-metal. So I think this one you already studied in form 5. So this is example. So you have sodium atom. So it transfer one electron and this is Cl atom. It gains one electron. So in the solid form, it is actually like this in cubic structure. Okay, so how to draw ionic bond using Lewis dot symbol? So for example, this is example of questions. Show the formation of the following compound using Lewis symbol. Okay, so there are two questions here: sodium fluoride and lithium 2 oxide, Li2O. So the first one, sodium fluoride. I think this is the sodium fluoride in your toothpaste. So how to write this down? So first you write down Na and its electron, valence electron. So 1, and fluorine it have 7. 1, 2, 3, 4, 5, 6, 7. Okay, I put the electron here because easier for you to see. So this is ionic bond. So ionic bond, it relates to transfer of electrons. So Na transfer the electron to fluorine. Okay, so I want to draw the formation. So the electron from Na transferred to fluorine. So what will happen is you put a bracket because now it become ion. So Na now become positively charged, and there are no more electron in Na because all of the electron is being transferred to fluorine. Okay, maybe before this, to differentiate between the electron from the Na, you write down X, right? But for this matriculation level, no need. We know it is from Na, so no need to put X. And fluorine here is negatively charged. So this is how you are going to answer in exam: formation of ionic bond using Lewis dot symbol for sodium fluoride. If the question asks you about sodium fluoride. Okay, what about if you have two atom, two same atom? Okay, so the same thing. You just need to draw two. So lithium 1, lithium 2 plus oxygen is 6, right? Valence electron 1, 2, 3, 4, 5, 6. Okay, so this one transfer one electron here, and this one transfer one more electron here. So you will get lithium that is positive charge, but there are two lithium. So 2 you put here. Do not put it here. No, that is wrong. 2 you are going to put at the front here. And oxygen. Oxygen now gains one electron from both of the lithium. So you get octet. So this one become octet. So this is for ionic. That is how you are going to draw the formation of ionic bond using Lewis dot symbol. Okay, next, formation of covalent bond. So covalent bond is sharing of one or more pairs of electron, and this one happens to non-metal atom only. Okay, the question here, show the formation of fluorine. Okay, so fluorine, so we are going to show about fluorine. So fluorine is non-metal with non-metal, so you have covalent bond. So fluorine, 1, 2, 3, 4, 5, 6, 7. Okay, plus fluorine, 1, 2, 3, 4, 5, 6, 7. Okay, do I need to draw the arrow? Okay. No need to draw the arrow for covalent bond because this is not about transfer of electron. It is not fluorine at the left here transfer electron to the fluorine on the right. So no need to draw arrow. You just write down the sharing of electron between fluorine and fluorine. Okay, so like this. Or you can also draw, because it already happens to be bonded, so fluorine with fluorine. Okay, now what happened is this is what we call bonding pair, the electron that is used for bonding. So we are calling it bonding pair. And the one that is not used for bonding, all this that is not used for bonding, and even this one, we call it lone pair or non-bonding pair. Okay, so lone pair. Anything that is not used for bonding pair, we call that lone pair. Okay, more example. Example 3. Where is example 2? Okay, this is the example that I take from your notes. So example 3 refers to the one that is in your notes. Okay, so PCl5. PCl5 is covalent bond. So you need to determine first, is it covalent bond or is it ionic bond? So this is covalent bond. So for you to do PCl5, so write down P, you need to determine the valence electron for P, and it is actually in group 15, so 5 electron. Okay, and plus Cl. How many Cl? 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, there are 7 valence electron per unit of the chlorine. Okay, so how you are going to draw? So you are going to draw Cl, Cl, P, Cl, Cl, Cl. Okay, so this one you need to put the electron. So Cl must be octet. 1, 2, 3, 4, 5, 6, 7, 8. And the same thing lah. So each one you just put another 6 electron for each of the chlorine. Okay. But P here is not octet, right? Okay, P here is not octet. Okay, even though it is not octet, this is actually more than octet. We can see that it is more than octet. So is it possible to have more than octet? What does it mean by more than octet? Means that it have more than 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 electron, 10 valence electron at P. This is possible because phosphorus have exception. We call that expanded octet. Okay, expanded octet. Okay, now we are going to proceed to draw Lewis structure. Okay, Lewis structure. What is Lewis structure? So Lewis structure, also known as Lewis dot formula, Lewis dot structure, electron dot structure, Lewis electron dot structure, Lewis dot symbol, are diagrams that show the bonding between atoms of molecule as well as the lone pair that may exist in the molecule. So example, this is CCl4 or tetrachloromethane, CCl4 or carbon tetrachloride. This is ammonia or NH3. Okay, shown for you is bonding pair, bonding pair, bonding pair, and lone pair at the central atom. So the same thing for this one, ozone, bonding pair, and lone pair, lone pair, lone pair, lone pair. Okay, so the step to draw Lewis structure. Let's say the question asks you, okay, draw the Lewis structure for CH4. Draw the Lewis structure for CH4. Okay, so how are you going to draw it? Okay, first what you need to do is to count the valence electron. So step 1, valence electron. Okay, there are 1 carbon. So the valence electron for carbon, you need to refer to maybe periodic table. So there are 4 electron, 4 valence electron. And there are 4 hydrogen. So there are 4 valence electron, 4 hydrogen. So 4 plus 4 is 8. Okay, so that is step 1. Count the valence electron. The more electropositive atom is the central atom, except H. CH4, H is actually more electropositive, but it always become terminal atom. So your central atom is actually carbon. So we write down carbon as the central atom. Draw single bond to terminal atom. Okay, so anything that is not central atom is terminal atom. So you put the H surrounding the central atom. So carbon is central atom, right? And draw single bond. Draw single bond. Okay, now what you need to do is to count how many electrons are used. So this one is bonding pair, right? This is bonding pair, right? And for bonding pair, it means that each of the bonding pair, there are 2 electrons. And now there are 1, 2, 3, 4 times 4. So how many electron has been used? So 8 total electron, right? So 8 electron is already being used. All of the valence electron is being used. There are 8 valence electron and all the electron are being used for the bonding pair. Okay. Add electron to the terminal. Okay, we cannot add the electron because we already use all of the electron that is available. Okay, to make the bonding pair. And also H is duplex. Okay, duplex means that it only have 2 electron at the valence shell. So that is correct lah. So hydrogen here have 1, 2 electron lah. Okay. And what about carbon? Carbon here central atom is octet 1, 2, 3, 4, 5, 6, 7, 8. Okay. Carbon here is octet. This one also does not apply because we already use all of the electron. If the central atom doesn't octet, okay, this one also does not apply because it is octet. Okay, next one, determine formal charge. Okay, so formal charge, for you to calculate, you need to use this formula, total valence electron minus total lone pair plus half of total bonding pair. Okay, what does this mean? So let's look at hydrogen here. Okay, we want to calculate the formal charge of hydrogen. So total valence electron for hydrogen is 1 minus total lone pair. How many lone pair? 0. Plus half of total bonding pair. Okay, this is one bonding pair. One bonding pair, it have 2 electrons. Okay, one bonding pair have 2 electrons. So it means that this is 1 minus 0 plus half of 2 is 1, right? 1. So this one is 0. Okay, so formal charge for hydrogen here is 0. Because all of the hydrogen are identical, so all of these are 0. All of the hydrogen formal charge is 0. Okay, what about the carbon? Okay, what about carbon? If we want to calculate the formal charge for carbon. So for carbon, the same thing. Valence shell, valence electron, 4 minus lone pair 0 plus half of bonding pair electrons are 1, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay. So this is actually 4 minus 4, which is 0. So carbon also 0. So all these are 0. Okay, what does it mean by formal charge is 0? Okay, formal charge, when it is 0, it is stable. Okay, we can say it is stable. Anything that is too negative or too positive is not stable. Okay, so we actually tries to find a structure that have all of the formal charge is 0. But if there is negative charge, we want to make sure that the negative charge is on the more electronegative atom. If it is positive charge, formal charge, we want that charge is placed at more electropositive atom. Okay, I cannot further explain it. Maybe it can confuse you more. Okay, next one. Step to draw. Okay, I have sort out everything here. So C2H4. Okay, now you have 2 central atoms, but the step is the same. So the first one, count the valence electron. There are 2 carbon, so 2 times 4 is 8 electron, and there are 4 hydrogen. 1 times 4 equals to 4 electrons, so this one is 12 electron. The more electropositive is the central atom. Okay, so you have 2 central atom, carbon and carbon here. Draw single bond to terminal atom. Anything that is not central atom is terminal. So there are 4. So you need to spread this up symmetrically. So 1 hydrogen for carbon here, 1 here, 1 here, and 1 also here. So draw the single bond for each of these. Okay. Okay, this one done. Add electron to terminal atom. Okay, so you need to count first. So 1, 2, 3, 4, 5. 5. So you have 5 bonding pair times 2. So there are 10 electron has been used. So you have extra 2 more electron. Okay, 2 more electron. So where do you want to put the 2 more electron? Can you put it at H? Okay, no need to put at H because H is already duplex. Okay, H is already duplex. So you can put at either of this carbon. Maybe you want to put it like this, right? Okay. Do not put it like this because it's still not octet. Okay, this carbon 1, 2, 3, 4, 5, 6, 7. Okay, this carbon is still not octet. What we are looking for is octet. Okay, so step 4 here we don't put a terminal. So leftover electron, we place it at the central atom. So we need to do something like this. Okay, so you need to put both of the electron at the central atom, both of the electron at the central atom. So this one become octet now. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this one octet. But this one is not octet. 1, 2, 3, 4, 5, 6. Only 6 electron at carbon on the left here. So what can we do? Okay. If the central atom is not octet, consider double or triple bond. So what we need to do is we need to transfer the electron to form double bond. So this one will form a double bond. The electron form a double bond. So now let's calculate the number of valence electron at the central atom. 1, 2, 3, 4, 5, 6, 7, 8. So this one is octet already. So this one is octet. 1, 2, 3, 4, 5, 6, 7, 8. So this one also octet. So this is the final structure of Lewis structure of C2H4. Okay. And next, what we are going to do is to determine the formal charge. Okay, we already calculate if the H is like this, it is 0, right? So 0, 0, 0, 0. Okay, now what we need to count is this one. Okay, so formal charge for carbon here, if you still remember, total valence electron 4 minus lone pair 0, okay, plus half of uh half of bonding pair. So bonding pair 1, 2, 3, 4. 4 times 2 is 8. 8 because electron. So this one is 4 minus 4. So 0. So this structure is stable because it is 0. And also, this carbon is also identical with this one. So also 0. So every formal charge for this one is 0. So we have done everything to draw the Lewis structure. Okay, C2H2. Okay, this one C2H2. Okay, a little bit different. Okay, so the same thing. Step 1, count the valence electron. 2 carbon equals to 8 electron. 2 hydrogen equals to 2 electrons. So total is 10 valence electron that is available for you to use. The more electropositive central atom. So carbon, there are 2. Draw single bond to terminal atom. Anything that is not central atom is terminal atom. So you will put H symmetrically and then put single bond. Add E to the terminal atom. Terminal atom is hydrogen, but hydrogen is duplet already. So leftover electron placed in central atom. Okay. So how many bonding pair that we use? 3. 3 times 2 equals to 6 electron that we have used. So 10 minus 6 means we have leftover 4 electron. Okay. So what we can do is we can put this. Okay. So we have done this. If the central atom is an octet, okay, so is it octet? 1, 2, 3, 4, 5, 6. Okay, so this one is not octet. This carbon is not octet. Okay, this one is also not octet. So what can you do? What can we do? Consider double or triple bond. So we need to consider to move the lone pair from the central atom to this part. Okay, so let's do that. Okay. So is it octet now? 1, 2, 3, 4, 5, 6. Oh, still not octet. So how? Okay, we need to take this one to form another bond. Okay, let's do that. So now it have triple bond. Okay, triple bond. So is the central atom octet now? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this one is octet. And this one is identical, so it is also octet. So this one is triple bond. Triple bond. And that is the final structure for the C2H2. Okay, formal charge, how to calculate? H is identical. Okay. What does it mean by identical? It means that it only have one lone pair and one bonding pair and 0 lone pair. So this one is 0. The formal charge is 0. This carbon, how many bonding pair that it have? 4. 1, 2, 3. 1, 2, 3, 4. Okay. So when it have 4 bonding pair and 0 lone pair, it is also 0. The calculation will be the same like the previous one, C2H4, the same. It is the same. So we have determined the formal charge, which is everything is, and that's the formula. Okay, AlCl3. What about AlCl3? The same thing. Number one, AlCl3. So 1 Al, 3 electron, 3 Cl, 1 electron, so 24. So Al, and Cl is a terminal because it is not central. Draw a single bond. Okay, quickly. Add electron to terminal atom. Okay, now we can put electron at the terminal atom. Before that, you need to count this one, the bonding pair. So 3 times 2 equals to 6 electron for bonding pair. This is for bonding pair. So 24 minus 6, you have 18 more electron left over. Okay, this is the leftover that you can put in central atom. Sorry, this is this one. Add electron to the terminal. Sorry, not leftover. This is what is available for you to put at terminal atom. So what do you need to do for terminal atom? Okay, for terminal atom, other than hydrogen, you are going to octet it. Okay, so you already have 2 electrons as the bonding pair. So you need to put 6 more. 1, 2, 3, 4, 5, 6, 7, 8 plus with the bonding pair. So this one becomes octet. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 3 times 6 is 16. So you have used all of the 18 electron at the central atom. But what happened to central atom? You already put 18 electron at the terminal atom. So what happened at the central atom? Central atom here is not octet, right? Not octet. Okay, for aluminium, it have exception of octet. We call that what we call incomplete octet. Okay, incomplete octet can occur for beryllium, boron, and aluminium only. Only these three. Only these three. Okay, some people pronounce this verbal. So it might maybe easier for you to remember, right? But it is beryllium, boron, and aluminium all have incomplete octet, exception of octet. Okay, so 7, determine the formal charge. Okay, determine the formal charge. Okay, for the formal charge, the same thing, but this one is not hydrogen, so we need to calculate. So formal charge for Cl equal to total number valence of electron for Cl, which is 7, minus lone pair. How many lone pair? 6, huh? 6 plus half of the lone pair. Sorry, bonding pair. So bonding pair is 2. So 7 actually minus 7. So it is 0. When it is 0 means it is stable. So this one is 0, 0, 0. So all these are identical. And aluminium? What about aluminium? Okay, formal charge of aluminium. Valence electron 3 minus lone pair 0, lone pair 0 plus half of bonding pair. Bonding pair is 6 electron. Okay, 1, 2, 3, 4, 5, 6 electron. So actually it is 3 minus 3 and still 0, and 0 is stable. So we have done everything. Okay, PCl5. Next one, PCl5. There will be a lot of exercise for you to understand this. Okay, PCl5. Valence electron 1 phosphorus equal to 5 electron. Cl, there are 5 Cl, so this one is 35 electron over, so total is 40. So which one is more electropositive? Phosphorus. So phosphorus. So phosphorus, so you are going to put Cl, 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 single bond. So there are 5 single bond. So 5 times 2 electrons, so equal to 10 electron from the bonding pair. So what's left for you is 40 minus 10. So you got 30 more electron to spread at the terminal atom. Okay. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so 6 electron per Cl. So 5 times 6 equals to 30, right? So now you already use up all of the electron to spread at the terminals. Okay, but now if you look at the P is more than octet. P is more than octet. Okay, this is also exception. This is also exception to to atom that is in period 2 and above. Okay, uh, uh, period 3, sorry, period 3 and above. 3, 4, 5 can have this more than octet. And this exception, we call that expanded. Okay, for formal charge, I think you can calculate. Okay, because the formula is the same. Okay, next one. CO2. Sorry. CO2. This is the last one. So step one, count the valence electrons. C is 4, and oxygen there are 2. So 6 times 2 is 12 electron. So 16. The more positive is central, so correct. So oxygen, draw single bond, add electron to the terminal. Okay, this is bonding pair. You are using 4 electron to make the bonding pair. So 4 is being used. So 16 minus 4 is 12. So you can spread 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have used all of your electron to terminal atom. But the central atom is not octet. Okay, so this one is not octet, but is it expanded octet? Is it incomplete octet? Incomplete octet can only be beryllium, boron, and aluminium, and this is carbon, so you cannot have incomplete octet. So what you can do is the electron can be transferred here. Okay, and also this electron can be transferred here. Okay, so what will happen? So let's see. So when the electron is transferred, what you get is a double bond. And now is it octet? Carbon 1, 2, 3, 4, 5, 6, 7, 8. So this one is octet, and this one also octet. The oxygen also octet. But this is not the only configuration that it can have. You can also transfer from the same oxygen. Okay, so this one, let's say it will become like this. Okay, but this one is this one also correct. This one also correct. Sorry, in terms of drawing, this one is correct. Okay, both of the structure is correct. Let me label it first. So let's say this is compound A, this is compound B. So which one you choose to be more correct? Is it A because it is symmetry? Okay, actually, the one thing that we use to determine whether A or B is more possible, we are going to determine the formal charge. Okay, so formal charge for this one, let's calculate for oxygen. So formal charge for oxygen equals to valence electron 6 minus lone pair 4 plus half of bonding pair is 4. So 4 times 2 is 6. So 0. So this one is 0. This one is 0. And carbon here, because it have 4 bonding pair, if you still remember from the previous calculation that we have done, also 0. Okay, but this one, what happened is, formal charge of oxygen here is 6 minus, okay, lone pair is only 2. Okay, lone pair is only 2. Minus half of bonding pair, that is 6. 6, 1, 2, 3, 4, 5, 6. So this one 6 minus 2 plus 3. Okay, 2, sorry, plus 3. Fine. So this one is actually positive 1. Okay, positive 1. Okay. And for this one, this is not identical, so you need to calculate. So F formal charge for oxygen here, 6 minus lone pair 6 plus half of bonding pair 2. So this one is 6 minus 7. So this is negative 1. Okay, but carbon here, 4 bonding pair, right? 4 bonding pair means this one is 0 lah. So as you can see, one of the oxygen is negative and the other oxygen is positive. Positive 1 and negative 1. Whereby this one, everything is 0. Okay, so formal charge we can use to determine which one is more possible structure. So actually, the structure that we are going to use is this one. So for the final drawing, we are going to choose this one. Okay, so that's it for Lewis structure. Good luck. Bye.